Hi, my name is Dylan and this is my final project. In 1907, the first synthetic polymer was synthesized by Leo Baekeland. As the invention of bronze dawned the Bronze Age and steel the Iron Age, the first man-made polymer began the Polymer Age. Plastic is made up of long chains of repeating molecules, and through chemical engineering techniques, we can cheaply mass-produce synthetic polymers or plastic to whatever specifications we desire. It can be lightweight and flexible, like a disposable water bottle, or rigid and sturdy, like a PVC pipe. We find plastic in the packaging of the food we eat, technology we use, and clothes we wear. One trait all plastics have in common is they are extremely durable. Regardless of how long we use them, they will remain as waste or in the environment for hundreds of years. The slow breakdown leads to a buildup over time, and now we are stuck with plastic pollution. It may feel impossible to avoid in 2022, but plastic was not popularized until after the Second World War, and in the last 70 years we have produced so much of this wonder material, traces of it can be found in all corners of the earth. Plastic pollution has been known to be a problem for a while now, and I decided to investigate how our changing behavior and new widespread uses of plastic encouraged by the pandemic has impacted pollution. Pollution is a tricky problem to deal with because by every metric it tricks our risk perception. As we can see by this chart, nearly every adjective that lowers our perception of risk applies to our use of plastics. This table effectively captures how, depending on the nature of a threat, our feelings towards something versus the likelihood we incur harm can be wildly different. In order to understand the pandemic's impact on pollution, we must first have an initial baseline. This first chart is from 2015. Up to this point, we had produced 8.3 billion tons of virgin plastics, 60% of which is already waste. Looking at the trend over time, production is clearly accelerating. It looks like we have already exceeded 10 billion tons and counting globally. A critical change happened in July of 2017 when China issued a ban prohibiting imports of foreign garbage. The flow of plastic waste into China had reached nearly 9 million tons annually and, as seen on the right, abruptly ended. In November of 2016, a documentary, Plastic China, was released. It showcased the material conditions of two families working in the quote-unquote recycling industry. With little dialogue or data, the filmmakers eloquently captured how our consumption, while in our past, dictates one little girl's future. This documentary was not the only thing triggering the waste ban, but chronologically it does fit. The film certainly caught the attention of the Chinese government, as it is now banned, along with all dialogue surrounding it. So, what about pollution? Conveniently, much plastic pollution in the ocean coalesces, forming the Great Pacific Garbage Patch. With much of the waste migrating to one region, it becomes easier for us to measure. One might even say this is a positive externality of the Great Pacific Garbage Patch. A 2018 article in Nature was headlined, "Evidence the Great Pacific Garbage Patch is rapidly accumulating plastic." Commercial fishing equipment, mostly in the form of nets, makes up half of the Great Pacific Garbage Patch by mass. This waste, as well as ships dumping blage directly into the sea, deserves attention but is outside our scope. Our focus, mismanaged plastic waste, enters through coastal zones and via rivers. In 2018, rivers' direct input of plastic to the ocean was estimated at 0.5 to 3 million tons annually. As shown in the figure, about 3% of the plastic waste makes it to the ocean. It's important to remember here that 270 million tons is 2015 data. We likely have doubled the primary production and waste over the last 2 years. Each aspect discussed so far points to converging trends, all before the pandemic struck. With this in mind, we can ask, how did the pandemic impact plastic waste entering the ocean? Our behavior has clearly changed, with many of these changes resulting in increased plastic waste. Takeout food was popularized, health protocols encouraged single-use items, and acrylic dividers were installed in public places. A spike in production with downstream spikes in waste and ultimately pollution. Again, converging economic and political trends worsened the problem. Crude oil, the feedstock to plastic products, hit a two-decade low in price from March to November 2020, meaning virgin plastic was cheaper than ever to produce. Further, as shown on the right, many states and municipalities deprioritized plastic pollution mitigation measures that were in place as a response to the chaos induced by the pandemic. When thinking about the fate of this waste, I find this chart very useful. First, we see the breakdown of plastic usage by application. 40% goes to packaging, which unfortunately has the shortest lifespan. By these figures, 40% of all new plastic produced goes to waste within a year. We used some plastic for medium or long-term applications, but the reality is, without a circular economy, All plastic now in use, including basically every item in our homes, will be waste within our lifetimes. I can't help but mention the risks of endocrine disrupting compounds such as phthalates and BPA that are present in everyday items. Pair this with microplastics, the risk organic chemicals pose for bioaccumulation, and the track record of petrochemical companies poisoning first, settling later, and the chemical pollution aspect of this problem is formidable. Our behavior will have downstream impacts, if not immediately for us, certainly elsewhere globally. So, what can we do? Risk assessment and scientific communication are certainly part of the solution. Many people are unaware of just how out of hand this has gotten. The current practices are diametrically opposed to sustainability. We take a very energy dense, finite resource in oil, process it into a product that will last for 500 years, use it once, and dispose of it, often irresponsibly. It's generic to say we must end our dependence on fossil fuels, but it's true, and the integral role plastic plays in our lives is not adequately addressed in this conversation. This is not just a talking point. Anthropogenic domination of the environment is not the only path forward. As this figure shows, through a symbiotic relationship with nature, we can harness its immense power to meet our society's needs. As environmental engineers, we have some of the best tools to realize solutions. An example would be life cycle assessments. As these become more robust and accessible, we can answer questions like what is the most environmentally friendly way to shop and eat. There is an element of choice here. There are often better or worse choices, intentional or careless actions, and this notion of individual responsibility is part of the answer. However, until a systematic solution for a closed-loop waste management system addressed and realized on a global scale is realized, our exposure to EDCs and microplastics will continue, and the Great Pacific Garbage Patch will keep growing. Now is the time to think about our own priorities and our priorities as a society. If clean water in the future is something we value, we must commit now to mitigating pollution and see it through.